This will be a tutorial on how to measure particle size and morphology on ImageJ, which we will use for the remaining pulsar studies. So I'll go through start to finish with two examples, both of them with Kaha. One will be with undilute, one will be with 1 to 2. So first step, obviously you open ImageJ FIJI, and FIJI just stands for Fiji is just ImageJ. So this is an updated ImageJ. One thing that you'll have to do before you start image analysis is download a plugin. And the plugin that you'll download is called BioVoxel Toolbox. Now, in order to download the update, and if you'll notice, this is just the working ribbon for ImageJ, but up on the top left on this part of Mac is our command prompting. So under Help, you will go to Update ImageJ. Click that. Make sure you're running the most up-to-date, which I am. So we'll click OK. And it will restart if you don't have the most up-to-date version. And you will go back to Help and click Update. And it will prompt sort of an update tab here. And it will pull up an updater. And you will click Manage Update Sites. And make sure you've got ImageJ and Fiji and Java 8 selected. And then also scroll down and click BioVoxel and BioVoxel Figure Tools. And then you'll add them and click Apply and Close. And when you do that, you'll have to restart ImageJ one more time, and you will have BioVoxel plugged in. You can click on it now, just click BioVoxel Toolbox, and it will bring in this pink cube, and we will use that later. So this ribbon up here, this is Fiji, and all of the commands are housed inside of these selections, and all of the processes are ran through these prompts: file, edit, image, process, analyze, plugins, window, and help. So to open an image in Fiji or in ImageJ, you just simply drag and drop onto the bar like that. And this is undiluted radius, as you can tell from all of the strands in here. So the first thing that we're going to do is calibrate the scale for our measurements. And the way you navigate an image on Fiji, you can click the hand tool and it will drag you. You can drag around the image. But then to zoom in and out, you just click the plus or the minus sign and it will zoom in on wherever you have your cursor pointed. So in this case, the first thing we're going to do is zoom in on the calibration bar. I'm going to zoom in to try to be accurate. And then you'll click this straight tool, this straight line tool, and you'll drag this line over the length of the scale bar. And then you'll go to Analyze and click Set Scale. And it will give us the distance that this line is in pixels. And then it will allow us to input our known distance, which in this case, this is 10 millimeters. And we will change our unit of length to millimeters. We'll make this a global change, and we'll note that the scaling here is 46 pixels per millimeter. You can click OK, and then you can zoom yourself back out. So, and to get rid of this line on the screen, you can just click Escape, or you can click anywhere outside. So the next thing we'll do is define a region of interest. And since we're using a petri dish, we want this to be round or ovular. So click this oval button, and then we will just drag the region of interest here, like this. And you can try to just include as much of the particles as possible. Once this is defined, right-click, and then we'll select Add to ROI Manager. And that will bring up this box that is your ROI Manager. And if you were to close this image and then reopen it and then click on this, it will overlay that ROI again. And we can rename this as undilute haha sample. And you can save these ROIs, right click, you can save it for later if you need to come back to the analysis, but it's good to have your ROI defined in case you accidentally lose the ROI during processing. But now we want to clear essentially everything outside of this oval, outside of our region of interest. And to do that, we'll click Edit up here and then Clear Outside. And that will define or remove everything other than what's inside of our region of interest. Now, before we start analyzing the image, we'll convert it to grayscale, which is black and white. We'll go up to Image, Type, and click 8-bit. Now we're going to threshold the image, and to do that, we'll pick a random area, let's say maybe here, and zoom in on it. And our goal now is to highlight the fragments here. And to do that, we'll click Image, Adjust, Threshold. And the threshold will automatically adjust based on the image. And you can tell this automatic threshold was actually pretty good. I'll zoom in on a couple of spots and just sort of check it. So it looks pretty good. But we can edit it and by moving these sliders. So if I move the top slider to the right, it'll essentially cut off darker black values, but those are the ones that we want. And then this big gray hump here is probably the background from the Petri dish. It is. And so you can sort of slide that until you have an appropriate amount of particles highlighted. And once that's done, you just click Apply. And it gives us this. Now, one thing you'll note if we zoom in here is that these are not these are individual segments, but if we were to try to measure them, and I'll show you how to measure an individual, you can click this magic wand tool and double click it and increase the tolerance to 40 and click OK. And then if you click on something, it will highlight it in yellow. You can see that this is outlined in yellow here. And if we were to measure this, then you can see this highlights the entire blob. And so we need to create separations between these chunks. And to do that, we have to threshold or watershed the image. And we'll do that with biovoxel. So click the pink cube and click Watershed Irregular Features. Click Preview. And then change this to 10. So you can see that was too high of a watershed. So let's decrease it to 5 and try again. So 5 looks decent. And you can spot check with, let me close this log box. Click OK. And we can spot check by highlighting with the magic wand tool. This looks fairly good. It's not going to be perfect ever, but this did seem to be good, so we can progress. Next thing we'll do is click on our ROI, and it will bring in and only measure particles inside of this region. And the next thing we'll do is measure them. And so we'll go to Analyze and Set Measurements. The measurements that we want to measure are area, shape descriptors, integrated density, area, mean gray value, perimeter, and median. We also want to display the labels, and we want to limit to the threshold that we set. Click OK. Go back to Analyze and click Analyze Particles, and that will open another box. And here we can define the size of the particles that we want to measure. So in this case, we don't want the background noise, and it does look like we've got some. So we'll define the minimum for about 6 pixels. And I think this is a good, actually let's bump it to 8 pixels. A good approximate cutoff. And instead of using millimeters squared, we'll use pixels. We also want to display the results. We want to clear existing results. We want to summarize the values. We want to exclude fragments that would be sitting on the edge of our ROI. And we would want to overlay. And we want to overlay masks. You can pick outlines, masks, anything, but I prefer overlay masks. And then you click OK. And so you can see we've got this aggregation of pop-ups. The first one is the summary data, where we can see that we had 1,855 particles that were identified. This is our average size. This is our average area, etc. And this is all of them individually labeled. So we can spot check this by zooming in, and we can see that this did a fairly good job. So these tiny, tiny little specks didn't get counted, but these obvious microspheres did. So I think 6 is pretty good with 5 threshold cycles. And we can always edit out, and you can see down here that these bigger chunks got excluded because they were sitting on the edge of our ROI. You can see in a couple examples like this one, it closed the hole. That was basically in the configuration. We'll have to edit that out or filter out that data when we're analyzing for significance. So that's how you do that. If you want major or minor axis included, go back to set measurements, and you would do fit ellipse, and that would give you the major and the minor axis length. So that is how you do that. I'll pull open the results again. You can right click, save table, save as. You can save this as an Excel or a CSV. You can also summarize the results again if you need to, and it will do it at the end. It'll give you the mean, SD, min, and max values. You can also plot it. So if you wanted to look at it briefly, your X could be area, your Y could be, we'll say, integrated density. And so that is essentially the area and the fluorescent intensity. If you want to visualize this at all, you can. I don't really think it's worth your time to do it. But also, if you want to look at the distribution, you could do that. If we want to look at area, mean, major axis, minor axis, whatever you want, we can do that. Maybe we say 20 bins, and then click OK, and it will give us distribution frequency. But we can do that also in the stats package that we will run. That's how you do that. Hopefully that is helpful to walk through the process. I'm now going to switch to, I think, a more difficult measurement, which is the hyperdilute radius. So I'm going to close this. I'm not going to save it. I'm going to close this, but I'm going to leave this in the ROI manager just so I can show you how you would overlay in another image. I'm going to open Finder, and I'm going to drag in the hyperdilute radius sample. And just to show you, if I click this, it automatically puts in my ROI. And in this case, it's actually pretty good. That almost looked even better, but we'll do the same thing here, which is start to finish. So first step is calibration. Click on the line tool and set the scale. So go to Analyze, Set Scale, and this is almost exact with the carryover from the last one, which is good. Click OK. Zoom out and apply that same ROI. If you click the wand tool and double click it and your tolerance is at around 40, it will define it within the Petri dish, which is not bad. So however you want to do it, it doesn't matter. And then click Edit, Clear Outside. Now we've got our ROI fairly defined. Where this is going to be difficult is because this is powdered Kaha. You can see these are tiny flakes. Thresholding will be kind of hard, but nonetheless, go to Image, Adjust Threshold. Oh, I forgot to convert this to 8-bit. So turn it into 8-bit and then adjust threshold. And we are way over thresholded. So let's pull that down. And then in this case, you're going to have to zoom in a lot. These are obviously individual microspheres, but it should look like powder. So let's continue to adjust this. I think that's fairly good. Zoom in here on these. So I think that's decent. Click Apply. And this is kind of what we see with the microscope. I don't like that this ROI included this edge. So I'm going to refit an oval. And add it to our ROI. Right click inside of it, click Add to ROI. Rename it, we'll say Hyperdilute. Click OK. And then let's clear everything outside of there again. Okay. Now go back, we'll have to watershed this image. In the biovoxel tool, go down to watershed irregular features. Zoom in also on the image here before we do that. And let's pick some spots. So grab the wand tool and spot test. So like this should be smaller aggregates of tiny particles, not one giant chunk. So click out of there, click the biovoxel tool, watershed irregular features, and we'll do 10 erosion cycles. Click preview. So we can see that that did a decent job of breaking this stuff up. Let's switch it to 20. Click preview. So that looks to be about as good as we'll get. You can click OK. And click Analyze and Analyze Particles. For the size here, we'll leave it at 8. But now instead of infinity, I think we should go back in and figure out the size of some of these really large aggregates. That way we're not accidentally counting them as individual particles. So something like this big is obviously not going to be an individual aggregate. It's basically erroneous coupling, and we'll pick this bigger one. Click on that and click measure. The area that we have is 0.15, so I think we can make a threshold of our particle analysis at 0.15, and that will make sure that we're not accidentally including particles that are too big. And so click Analyze Particle again. This time unclick pixel units, and we'll do this minimum size of 0.0005, and then we'll do a maximum size of 0.15. Click OK, and it will give us probably a lot of particles that it's still measuring. Here's the loading bar, by the way. Okay, so we have approximately 39,000 particles that are counted. You can zoom way in, and we can take a look. So these tiny ones, they might be microspheres, but they're probably not. But these are all clearly microspheres. Another note, I actually should go back and do this for this one, and you could do it for the other ones, but once this is calibrated, it's probably favorable to remove the area that has the lettering in it so it doesn't skew the data. Real quick, I'm just going to run back through that to show you how to remove that. So if I drag this back in and reopen it, at first I'm just going to make sure that my calibration for the scaling is okay. And I'm just going to drag this approximately, maybe. I'm going to drag the freehand tool over the top and click M on the keyboard that measures it. So I'm going to look at my, going to clear all those results and the summary data. I'll click M. The length here should be 10. So this is okay. It's still calibrated. Zoom out. Apply your ROI with hyperdilute. Click edit and click clear outside. Now let's draw a couple boxes around our lettering, like calibration slide. So click the rectangle and draw a little box around them. Go back to edit and click clear. That'll remove it. And then do the same. You might as well do the same here because we don't want the lettering to mess this up. Click edit and clear. And then now we'll do the thresholding. So convert it to an 8-bit like that. Zoom in. Click image, adjust, threshold. You can click auto, but I think that is probably a bit too much. Zoom out. It should look approximately like the powder that we saw when we were under the microscope, so I think that's pretty good. Click apply. And now we've got this big powdery mess. Zoom in on some of the large aggregates, like this giant one. That would be, an individual piece if we measured it with the wand. Go back to biovoxel right there and watershed the irregular features. Our erosion cycle number will be 20. Click preview. Oh, make sure you can see I'm still highlighting this only this tiny piece. We want to click out of this and make sure that we're not just measuring that one. So just click any of these shape tools, click outside of the wand, highlight, and then redo this. Or else it will only apply the watershed to the area that you've selected. So we'll do 20. You can preview it or not. Let's zoom in and take a look. Click OK. So now it's broken these things up. We'll do the same thing with our thresholding for the size. Click Analyze and Analyze Particles. It's going to save that from before. And I think this is pretty good. We can maybe drop this down to 0.4. And maybe drop this down to like 0.12. And then we will click OK. So we had 75,000 now, so that's small change from 0.0004 to 0.0005. cut out about half of these particles. And it's good to spot check this again. So zoom in. This is now obviously a massive file. And the question, so I think 0.004 highlighted some noise. So really I would stick with 0.005 as the threshold. But that is it. There's the summary data. Here's all of the individual results. And that is how you do it. That is it.